So, good evening to all of you. So, today is the just wait. Sorry for the disturbance. Okay. So, today we discussing for gate syllabus. So, this is the related for highway engineering. Okay. So, before that, I'm giving the introduction about this area of the subject. So, we are expecting. So, serial number 3, transportation engineering and highway engineering. So it will take for 30 hours. So the tentative marks expecting for the gate examination 9 marks. So this is for your information. Then I'm going to move to presentation notes. Yeah. So this is for the highway engineering. So preferably it is for competitive examination subject. So it is commonly for IAS also. So for a highway engineering, so the topics which is related to the highway engineering and planning, highway development and planning. So this is for highway alignment, highway geometric design, highway materials, pavement design, highway maintenance and drainage. So these questions, area of the questions are expected for our gate examination. So this is for land, airway, waterway. These are the most transportation methods. So these transportation methods are look like that. Um, just wait. Sorry for the interruption. Okay. So these are the most transportation methods. Okay. So land, airway, waterway. The questions are exported from the land. Okay. This is called as a highway engineering. Okay. So airway and waterway should be separate of a topic. That way it will be possible for IS examinations. So the topics from the transportation. So roadway and highway and railway. Okay. These are the three important parts. Okay, road and highway. So this is the same pattern, same criteria. And railway, it should be as a different of a transportation method. Okay, these two method of transportation is only on the land surfaces. Okay, So another 3 and 4 should be an airway and waterways. Okay. So first, the most flexible one, the highway and roadway. Okay, highways are to the high plus way. Okay, so this is called as a highway. Okay, the broad of that road dimension, it should be has a go for flexibility, that is called as a high and plus way. This is called as highway. So in order to avoid the drainage problem and as well as for the maintenance, road is laid and elevated in some height. Okay, so for the reason, what is the reason for elevated? Okay, it is for the avoid the drainage problem. Okay, so mainly the elevation is applied for in that road surfaces. It should be has for maintaining the, so avoid the drainage problems. Okay, as well as a maintenance also. This is called as a elevator. The next, in India, mixed traffic system. Okay, we are following only for the mixed traffic system. Okay, in the foreign abroad countries, so separately, so for individual traffic system, separate traffic systems, they should be followed. Okay, but our Indian culture of the traffic management system, so we go to follow for mixed traffic system. Okay, what is mixed traffic system? So this mixed traffic system is suitable for car lane, bus lane, truck lane. Okay, all the vehicles are go to mixed of the way. So this is the best example for a mixed traffic system. So now the next, geometric design. What is maybe geometric design? Okay, this is for the width of the pavement or carriageway. Okay, so this is called as a geometric design. Okay, so the geometric design, the width is also called as a carriageway. The road maximum of the width, it should be also called as a carriage ways. So this is the center line. Okay, the total of the road width is a carriageway. The center dot white line, it is called as a center line. So that is a lane 1 and lane 2. Okay, lane 1 goes to the left, lane 9 goes to the right. Lane 1, 2 goes to the right. So this is the base example. Okay, so one question is available for Indian Road Congress IRC. Which code is established in the first edition? It is for the 1934 in the year of Indian Road Congress. It should be formed. Okay, the proper rules and regulations are available it from the Indian Road Congress 1934th year. Okay, so this lane is called as a two lane width. Okay, so as per IRC Indian Road Congress, we have to design only the road construction, road pavement alignment, road alignment. Okay, all the dimensions, geometrics, materials, dimensions are referred from the Indian Road Congress. Okay, we have to design. Okay, this is important. So road, it's called as a two lane width, two way traffic. Okay, so as per the Indian Road Congress, the maximum width of the vehicle, this is important. So question you have possible in CAT examination, what is the maximum dimension width of the vehicles? That is for 2.44 meter. Okay, this is important. 2.44 meter is the maximum width of the vehicle. Okay, for a design purpose, we have to run with the 2.5 meter. Okay, at least we provide the maximum width of the vehicle for easy transformation. Okay, and door lock. Okay, for offset distance, we have to provide for that. At least for a design point of view, we provide for 2.5 meter. It should be definitely important for road design. Okay, for a single lane road, okay, we constructing for a single lane road point of view. So this is for the road. Okay, road surfaces. So we provide for 2.5 meter is a width. Okay, and 0.625, 0.625, it should be F for offset. Okay, this is for the single lane road. Okay, this vehicle is goes to the half top of portion. Okay, so 2.5 is exactly vehicle width, and 0.625, 0.625, it is for offsetting, door open, lock, offset distance. Okay, so the maximum, sorry, minimum of offset distance, it should be 0.625 meter. Okay, so the totally the width of the road is for a single lane 3.75 meter, definitely we provide. Okay, so this is important. The next, clear way. What is maybe clear way? This is called as 0.625. So here the 0.625 is the offset distance, also called as a clear way distance. Okay, So for a village road, okay, we constructing village road. Width of the single lane is 3 meter. Okay, only one lane it is for 3 meter. Then clear way it is for 0.25 meter. Okay, this is for normal of a single lane road. In case of the construction for a village road means 3 meter it should be one, and 0.25 meter it is for clear way. Okay, so you can consider for 3.75 it is for single lane. In case of village road means 0.3.25 meter. Totally 3 plus 0.25 3.25. Next, width of a single lane multi-lane road. Okay, so you can see in the near of highways, some highways the center line, center median is not available. That road is called as a multiple lane road. Okay, so the width is for a single lane 3.5 meter. Okay, in case of it is a 2 lane means 7 meter, it is a 4 lane means 14 meter. That's all. Okay, the next, so 2 lane road width raised with curb. Okay, so the curb distance it should be 7.5 meter. Okay, including the curb distance also. KERB, curb it is the side shoulder. Okay, this is called as a curb distance. Okay, 2 lane road with a riser 7.5 meter. So this is the road surface, so this is a curb distance, also this is a curb distance. Okay, this is 0.25 meter, this is 0.25 meter. 250 mm is a concrete. Okay, the next, 2 lane road without raised curb. Okay, we have to constructing for a 2 lane road without the curb distance. Okay, this curb for the people's walkway and drainage purpose also. So in case of 2 lane means you have to provide for 1 meter. It is for center median. So 2.5 meter is 1 lane, 2.5 meter is 1 lane, 0.5 meter and 0.5 meter it is for the shoulder. This is called as a 2 lane road system. Okay, next, the intermediate lane. Okay, we have to provide for intermediate lane. It should be width of the 5.5 meter. Okay, this is the 5.5 meter. So example, urban areas. So you can see the most of the urban areas roads are in the of intermediate lane. Okay, so totally no center lines are available. So though borders only, left border and right border, it should be in the 5.5 meter of a distance. Okay, the next, 4 lane system. Okay, the 4 lane, the traffic separators. Okay, the traffic separators, it should be called as the center median. Okay, center line. Okay, center barrier, the name it should be available. Okay, center separator, traffic separator. So to avoid the head-on collision. Okay, so the main of a traffic separator work it is for the to avoid the head-on collision. The next, side distance, SD. Side distance, the abbreviation for SD in highway engineering point of view. So it is called as a side distance, SD. So also it is a Pave Duram. Okay, a clear distance. So definition, what is meant by side distance? The length of the road visible ahead to the driver at any instant. This is called as a sight distance. The next definition, the actual distance along with the road surface. So this is called as the actual distance along the road surface which a driver from a specified height. So we have to see all the particular particles. Okay, so for people's walking, two-wheeler and buses, cars, autos and grocers, trees, center median, okay, center barrier, okay, curbs, everything we have to see. Okay, as a specified height above the carriageway. Okay, it is called as a side distance. There has to be visibility of a stationary or moving object. So this is the side distance. So now for example, for height of the driver, it is a high level 1.02, so 1.2 meter. Okay, 120 centimeter. Okay, 1.2 meter, this is the height for a side distance for drivers, high level. Okay, we have in E of 1.2 meter high level. So the above the road surface, we have to maintaining for a 1.2 meter road surface on that people height, driver's height. Okay, driver eye contact of a level height in time during the driving. The next, type of a sight distance. So type of a sight distance, stopping sight distance. So emergency of stopping, diversion, okay, and it is a danger. Okay, we have to maintaining for stopping sight distance. The abbreviation for SSD, SSD. This is for as a stopping sight distance. The next OSD. OSD means overtaking sight distance. Okay, you have a possible questions in highway engineering point of view. SSD means stopping side distance. OSD means overtaking side distance. ISD means intermediate side distance. Okay, ISD, that is called as intermediate. Okay, the next, headlight side distance. Okay, so the headlight of the all the vehicle, buses, truck, car, auto, bike, all the vehicles have to be to see the clear sight distance. Okay, this is called as a headlight sight distance. The next, sight distance at intersections. So you have to moving the lane 1 to lane 2, lane 2 to lane 3 for a diversion, for a left to the right, or overtaking, any other point of view. So we maintain for a sight distance at intersection also. So first point, stopping side distance. So non-passing side distance. What is stopping side distance? So this road is for a nil. Okay, the point of view, this is called as a non-passing side distance. Overtaking means it is passing side distance. You can do it your passing side distance means it is called as a passing side distance, OSD. Okay, intermediate means we have to see during the time driving for a curb also, for a center median also, for a barrier also. Okay, we have to see in the clear of the light side ventilation side view. So this is called ISD. The next, headlight side distance, already we defined it. Side distance already intersection point. The ISD, intermediate side distance, it is shooter when overtaking the sight distance. Okay, you can see. So ISD, this is the shoot with the overtaking side distance. Okay, are provided side distance cannot be provided in the road. The width of the pavement depends on the pavements are traffic width, mainly number of lane. It should be provided for width. It depends upon the stopping side distance, SSD, stopping side distance. The length of the road required to stop the vehicle without collision. The height of the obstruction above the road surface. So what are the obstructions are available for a speed brake, barrier, curb, okay, and center median, okay, the vehicle distributor and lane distributor. Okay, these are the obstructions, okay, above the road surfaces. So this is for 0.15 meter, okay, or 15 centimeter. The unit conversion is important. At least we provide for a stopping side distance. Okay, SD, stopping distance, that is equal to SSD. Okay, stopping side distance. Okay, that is equal to absolute of a minimum side distance. Okay, the difference between the stopping side distance is equal to stopping side distance, stopping side distance. Okay, we have to maintain it for 0.15 meter absolute minimum side distance. Okay, so SD greater than SD means no collision occur. Okay, you can see stopping means higher. Okay, but stopping side distance, it should be very minimum. So here no collisions are occurred. So stopping distance minimum, which is less than of a stopping side distance, so collision is available. Okay, it should be occurred on the driving on the particular vehicle. Analysis point of view, SST. Okay, now you can see. So this is for the vehicle entry. Here the object whole site. So obstruction, it is for a 15 meter. Okay, the road obstruction is for 0.15 meter. So this is called as 15 centimeter. So this is for vehicle stage. Okay, this is for the braking distance and this is for the stopping distance. So this intermediate distance of 2 to 3, that is called as a brake distance. Okay, 1 and 2, this is for the lag distance. Okay, so the lag distance means here we need to observe for this obstruction. Okay, in case of you identify the obstruction here means we have to possible to stop the vehicle on the point 2. Okay, so this is called as a lagging distance, but we have to provide stop the vehicle in near of the obstruction, that is called as a braking distance. Okay, so this is called as a SSD. Okay, this is the brake distance, also stop distance. Okay, this is the main meaning. So no collision occurs means SD is always greater than, LC is always greater than with respect to the stopping side distance. In case of SSD is high, okay, with respect to the stopping side distance means compulsory we have to accident. This is important. Okay, so SSD L1 plus L2. Okay, SSD means lagging distance plus braking distance. So lagging distance, what is we have to find for lagging distance? V, that is equal to speed of the vehicle in terms of meter per second. Okay, vehicle sometime we have to meter per second. Our vehicle is goes to kilometer per hour. We have to reduce it for meter per second by T, that is equal to total R into N. Okay, so total times of the driver in times of second. Okay, and L1 we have to finding for V into T. V, that is called as a vehicle speed. T, that is called as the time of the driver. Okay, as per the Indian Road Congress, the total R into N time of the driver can be taken as a 2.5 second for a calculation of SSD. So you go to refer for Indian Road Congress code book. So that is for R into N. The vehicle drivers are moving to that time. It depends upon the vehicle speed in terms of second. It is for 2.5 seconds for calculation purpose. Okay, so you note it in a point. So this is called as a stopping side distance. So the definition, the distance of the traveled by the vehicle during the total run time is known as a lagging distance. So we have to finding for the lagging distance, that is L1. Lagging means it is available for here. So we have to finding lagging distance means the vehicles moving into the time. Okay, so the time it should be available from 2.5. So already we know the speed, then multiply we get it for lagging distance. That's all. Okay, so total run R into N time. Okay, it is for perception time, braking time. Okay, perception time it is for 1 and 2, braking time it is for 2 and 2. So lagging distance it is for perception time plus braking time. Okay, so L1 plus V into T, we know the formula. So V for kilometer per hour, it is given. T, it is from 2.5 seconds, so it is code book. So 1 kilometer per hour, that is equal to, so the unit conversion, it should be very, very important. 1 kilometer per hour, that is equal to 1000 divided by 60 into 60. 1 hour, that is equal to 60 minutes. 1 minute, that is equal to 60 seconds. For that reason, we have to change this one. Okay, 1000 divided by 60 into 60. So it should be converted to the meter per second. Okay, that is V into 0.278. This is the value for V, that is called as a vehicle speed 0.278 V into. Example, if vehicle is 10 kilometer per hour, our vehicle is going into the speed of 10 kilometer per hour. Okay, so we have to finding for the lagging distance V, that is equal to lagging distance L1, that is equal to, first of all we needed to find for a vehicle speed in terms of meter per second, because of our Indian road conquerors were available for that this time period. We have to take it for 2.5 meter per second only. For that reason we converting our vehicle speed into the meter per second. Okay, so V, that is equal to 10 into 0.278, that's all. Okay, this 0.278 is from this uh, equations. Okay, so meter per second is available. So L1, that is equal to 10 into 0.278, so into T, that is called lagging distance. So L1 we have to maybe for a 56 page, and brake distance is skid slip. Okay, so what is mean by braking distance? So already for lagging distance L1. So question is available. One of the vehicle is going to 50 kilometer per hour. Okay, you have to check it for a lagging distance. What is the value for lagging distance? Get examiner point of view. This question is expected for a descriptive question. So just you apply this formula and get a one of the value and fill it in the blank values, blank portions. Okay, L1 is equal to this one. Okay, so next level, braking distance. Okay, what is mean by braking distance? So when a vehicle is goes to the suddenly we need to brake on the road, it is called as a braking distance. So that braking it should be possible for skid, also slip. The two major components are the major problems occur during the driving, whether you apply for a brake suddenly. Okay, so skid and skip, how to avoid the skid and slip, how to maintain the for road construction, avoid during the construction of a skid and skip. The kinetic energy that is equal to half mv square. So you basically engineering mechanics you studied in that, for a kinetic energy that is equal to half mv square, half into mass of the vehicle into v, this is a variable member that is equal to equation number 1. So force into L2. The force of the vehicle into lagging distance 2, that is equal to L2. Okay, L2 it is for 2 to 3, that is called as a L2. 1 to 2, that is called as a L1. Okay, the force of the vehicle into L2. So F it is called as a frictional force. Okay, what is the frictional force? What is the force? So one of the load is directly applied on the object, that is called as a force. So one of the object is the surface transferred to the member, that is called as a frictional force. Okay, that member, that vehicle is on the road, that vehicle on the road it is moving to the nearly object obstruction means frictional. Okay, the tire is rolled on the road surfaces, the road surface is smoothly means the vehicle is goes to the higher speed, the road surface is dump and rise means the vehicle going speed is reducing. Okay, so for that reason we providing for a speed breaker. Speed breaker means we go to avoid for the vehicle speed rise to the down. Okay, so it is for a frictional forces. L2 it is a braking distance. Okay, lag for the braking distance. So we maintaining for frictional has no specific direction. So the friction has no specific direction. Why? Because of the friction. For it depends upon the road, it depends upon the vehicle, it depends upon the tire condition also. So F we finding that is equal to small f into W. Okay, small f into W into L2. Okay, we have to find for of mv square, that is equal to FW into L2. Okay, it in smooth surface F is equal to 0. In case of rough surface, we have to F is equal to 1. Okay, so we have to check it applying for these equations and multiply by L2 is unknown, so the values is for interchanging L2, that is equal to v squared by 2gf. This is the formula for finding the braking distance. Okay, L2 is equal to v squared by 2gf. V squared, that is m square by second square, g is equal to m by second square. Okay, L2 that is a braking distance in meter. Always the values are in meter only. F it is the coefficient of the longitudinal friction. The range of the F it is equal to 0.35 to 0.4. Okay, sometimes question is available. What is the range for the braking distance? What is the value for 0.35 to 0.4, 0.4 to 0.5? We choose by the any one of options. Okay. Next, if V, that is a kilometer per hour, the vehicle speed height is per kilometer per hour. So L2 that is equal to 0.78 V square divided by 2.2 into 9.81 into F. Okay, the vehicles are to the upper braking distance. The 9.81 for that vehicle speed divided by to obstruction means 9.81 into the vehicle capacity and the F. So the solving L2, this is a formula V square by 254 F. V square divided by 254 F. This is formula for L2. So finally, SST, stopping side distance, that is equal to L1 plus L2. Okay, totally we get for SST. Okay, in meter, SST in meter. So VT plus V square divided by 2 into F. So V is meter per second. So SST in terms of meter, 0.27 VT plus V square by 54 F. It is per kilometer per hour. So these two formulas very important. So question is given that in of the meter, you go to apply for this meter formula. A question is available for the kilometer, and you go to apply for these equations. That's all. Okay, the kilometer and meter it is for given by vehicle speed. Okay, so next topic, get examination, PIEV theory. Okay, PIEV theory. Okay, so that is related to the stopping distance only. Okay, that is total R into N time. Okay, so what is the PIEV theory? So perception, intellection, emotion, valuation. This is called as a PIEV theory. So the vehicle drivers are mostly this theory is important for smooth driving purposes for side distance. So perception, intellection, emotional, valuational driving. Okay, the next. The factors of acting is SSD. Okay, these are the factors very, very important for the SSD. So the total R&D time of the drivers. Okay, this is for the total R&D time of the drivers. These are the one of the factor. Runner time. Okay, number of the time. Speed of the vehicle. The vehicle capacity, the vehicle load, the road surfaces, the traffic flow, driver's capacity, okay, vehicle capacity. It should be for a vehicle speed of the vehicle. Then the third one is a coefficient of a longitudinal friction. So coefficient of longitudinal friction, it is only for a surface of the road surface. So the next, speed in terms of kilometer per hour. Your vehicle is goes to 20 to 30 kilometer speed, okay, or 40 kilometer speed, or 50, 60, 65, 80, 100. The coefficient of longitudinal friction, this is the tabulations, very important. Okay, so 20 to 30 means your vehicle, your coefficient of a longitudinal friction is 0.4. Okay, in terms of 40 means 0.38, in terms of 50 means 0.37, 60 speed means 0.36, 65 means 0.36, 80 means 0.35, 100 means 0.35. Why 0.4 to 0.35 reducing? Because of your vehicle is speed is very minimum. That means your vehicle tire is directly contact to the road surface, then only the friction is higher. But your vehicle is goes to the higher of the speed means your vehicle is goes to the directly not connected with the road surface. It should have a slightly flying. Okay, so for the reason this coefficient of longitudinal friction is a higher to lower. Okay, so your vehicle is speed high means the friction is low. Your vehicle speed is minimum means your friction is high. Okay, so it should be simultaneously available for your vehicles. Okay, the next fourth one, it is for the efficiency of the brake. Sometimes your braking system has to be failure. Okay, that braking system has to be one of the main reason for your vehicle or speed. Okay, the next, gradient of the road. Okay, the road gradient is very important. Okay, road gradients has to be some higher or down. Okay, and alignment is for improper means your vehicle speed it should be um collapsed. Okay, affected. The next, the exotopic, the effect of gradient on SST, stopping side distance. What is the effect? First one, for falling gradient. What is my falling gradient? That is called as a descending gradient. Okay, this is the falling gradient. Okay, the hills up to down, that is called as a falling gradient. Also, this is called as a descending gradient. Okay, descending means down, up to down. That is called as a descending. Okay, D and D. You go to for easy formula. SSDM, okay, stopping side distance M, that is equal to VT plus B square divided by 2GF minus 0.01 N. Okay, this is the formula for finding the SSD. Okay, the condition of the falling gradient. Okay, N, that is the percentage of grade. Okay, you go to apply for N, percentage of grade. Okay, and percentage of grade, that is equal to 1 by 25 into 100, 4 percentage. It's available for the grading system. Okay, for descending gradient means, in case of for rising gradient, ascending. Okay, rise means go to the up, this called as ascending. Ascending gradient means you know the formula for Vt plus b squared by 2g into f plus 0.01 n. So the down means minus, up means plus. Okay, directly surface. Okay, n example for 4 percentage. Okay, or you know apply for the formula and get it for 0.4 percentage. That's all. So n is equal to percentage of grade. Okay, the next, SSD downgrade is always greater than SSD plane is always greater than SSD upgrade. Okay, so the stopping site distance, okay, it's very high for downward direction. Okay, the total vehicle of the load, the total external forces, okay, the total surfaces in goes to downgrade, downstream. Okay, hills to down means your stopping side distance very near. Okay, we compare to the plane surface. In case of upright means your vehicle it should be in the of a minimum, and road surface is also to frictional, and you go to stop your vehicle with a minimum of maximum of a distance. Okay, that is called as a SSD upgraded. Okay, this is the uh, definition for stopping side distance for a hill, for a plane surface, for a hills down to up to down. Okay, so general form. So this is for general form. SSD, stopping side distance in terms of meter, that is equal to Vt plus V squared by 2G F plus or minus 0.001. This is the main formula. In case of your vehicle goes to the up means you apply for plus, down means apply for minus. The next, two lane with one way. So some of the population is higher. On our road, it should be converted for a two lane. That is one way. Okay. So sometimes two lane, it is in the two way. Okay, this is applicable for all the area, but an crucial area means we have to apply for one way. Okay, so SD that is equal to SSD. Okay, sometimes single lane with two-way traffic. So SD that is equal to 2 into SSD. Okay, what is meant to single lane? Okay, our stopping side distance is always equal to stopping distance, but two number of vehicles are flying to opposite direction, we have to multiply for by 2. Okay, here ST is equal to SST. The vehicle, two vehicles are smoothly run to the stopping side distance always is equal to side distance. Here the two lane means the one lane of the vehicle is goes to the one of a lane. The stopping side distance is equal to stopping distance. Okay, so the next topic for level 3. So the level 3, it should be for the safe of a stopping side distance for a design speed of 100 kilometer per hour in a national highway width of a 0.35 f, frictional coefficient f, that is for 0.35. Why 0.35 we have to choose? So the vehicle is going to the higher of the speed 100 kilometer per hour. Okay, so this for vehicle is higher means our friction is very low. In case of our vehicle is 20 means the friction is 0.4. Sometimes we have not available in the question, you have to assume. Okay, within the range of previous table. So stopping side distance, that is equal to Vt plus V squared by 2Gf. So for kilometer per hour, so we have to using this formula. Okay, SSD that is equal to 0.278 V into T plus V squared by 254F. So apply this formula and get safe side stopping side distance, that is equal to 181.98. So the answer D, that is equal to 182 meter in terms of meter. Okay, so again the recall of the table. So this is for our vehicle speed 40, 50, 60, 65, 80. Our friction is 0.38, 0.37 and 0.36, 0.35, 0.35 is available. Our for the safe SST design speed of the vehicle, we have to maintaining for the speed 182. Okay. So here in terms of meter, okay, so you have to maintaining for 44, year 61, year 81, year 91, year 127. This is for a maximum of speed allowed to the safe distance. Okay, the next, so this is important for your, you can see whether you driving the car or bus. So maximum speed limit is 16 kilometer per hour. The maximum speed limit is for 40 kilometer per hour, 20 kilometer per hour. Okay, this calculations are from this formula only. Okay, so next problem, the safe sight distance for a design speed of the vehicle 50 kilometer per hour for a two lane road with the friction factor that is equal to 0.37 meter is. So SSD meter, the formula is for 0.Vt plus V squared by 254F. So the formula, you can apply this one and you can get it for answer 61.35 meter. Okay. Okay. So This is for two lane. Okay, you have to apply for this calculation without the calculator. Okay, this is very important. First of all, you're resolving this multiplication and this multiplication divided by this one, and you will get for these equations. That's all. Then overtaking of a side distance. Now we are entering for the next topic, overtaking side distance. Okay, what is the overtaking side distance? So the overtaking is commonly for all the vehicle. Okay, the overtaking side distance, it should be of a clear side distance to avoid the collisions. Okay, so the mixed traffic system. So we have to follow only mixed traffic system. So for that reason, we have to take it overtaking. Okay, both the fast and the slow vehicles. Okay, so two-lane road with a two-way traffic, two-way lane and a two-way traffic. So this is for our practicing. Okay, here this is for the B. Here this is for the D2. Okay, here this is for the total D, and here this is for the D3. So here A1, A2, B1, B2, A3, C2, C1. Okay, the same speed we have to maintain it for D. B is equal to 100 kilometer per hour. This is for the our design consideration. All the vehicles are go to the 100 meter per hour. This is for our design criteria. Okay, but we limiting the speed is 80. Okay, to avoid the collision. Okay, so A, that is for the fast moving vehicle. Here the vehicle is go fast vehicle. B, that is the slow vehicle. Okay, C, opposing vehicle. Okay, so here the vehicles are moving, here the vehicles are moving. Okay, so this is for the distance. So this is for the two vehicle distance. So the vehicle distance only for face to face. Okay, or outer to outer, we can call any of one. The face to face means one vehicle front face and opposite vehicle front face. This is called the T1. Okay, so B means our front face to the back face means B. Okay, so C is opposing vehicle. So V is the design speed. We have to maintain it for 100 kilometer per hour. VB is for slow moving speed. Okay, slow moving speed we have to not to identify it. Okay, D1 means design traveled by the vehicle A during the position A1 to A2. Vehicle A1 to A2. Okay, this is in the range. So the though these two vehicles are goes to the, this A3. Okay, this is for overtaking side distance. So what is the speed? Okay, what is the maximum vehicle speed and what is the maximum width and opposite vehicle capacity, opposite lane width, and there's a road surface. So what is the dimension, what is the speed, we have to take it for overtaking, and we have to left it for the overtaking. That's all. Okay, so D1, this is for a distance traveled by the vehicle A during the position A1, A2. So D1, that is equal to VB into T, that is the R into N. Okay, so time is traveled, it is be R into N. Time of the driver. Okay, so that is T is equal to 2.0. You go to refer for T always 2.0 seconds. Okay, in Indian Road Congress. Okay, so alert of the driver, it means alertness of the driver. D2, that is called as the distance traveled by the vehicle A during the position A to A3. Okay, so D2 is equal to B plus 2S. Okay, S is equal to minimum spacing 10 meter. This is S means minimum spacing 10 meter. As per the Indian Road Congress, S is equal to 0.7 VBB 6 meter. Okay, where BB is meter per second, B is distance traveled by the vehicle B from the position B1 to B2. So we finding for a B is BB into time into T. That's all. So T is for overtaking time. That is for the taking of the vehicle A from the position A2 and A3. Okay. So one vehicle is from A, A2 and overtaking and A3. That's all. So T is equal to 4S divided by A into the root. So the formula, meter divided by A is meter per second square, that is equal to root of second square is second. Our values is to be as T second. A is the acceleration. So D3 is the distance traveled by the vehicle C from the position C1, C2. Okay, the opposite vehicle is also traveled to the one of the land, and after crossing that vehicle you have to take it a right and moving at the up rise of the speed and cross that B, and we are in the stage to the A3. That's all. So the problem, So finally, our vehicles on the speed is overtaking speed is D1, D2, D3. That's all. If overtaking distance D1 plus D2 means two lane road, okay, one way traffic or single lane, OSD, overtaking side distance, that is equal to 2B plus B plus 2S plus V into T. This is the formula. D1 is 2B, D2 means B plus 2S, D3 means V into T. That's all. Okay, so already this is a formulas. V minus 4.5 meter per second is given. D1, D2, D3, where distance speed of the spacing is 0.756. Already we know. So the overtaking side distance is always greater than with compared to the stopping side distance. Okay, stopping side distance is less than, okay, with compared to the overtaking side distance. This is important. Okay. So question, for a highway with the design speed of 100 km per hour, the safe OSD, overtaking side distance is, what is the value? Assume A is equal to 0.53 meter per second square. A is the accelerator as per the our Indian road conquerors, 0.53 meter per second square. This is for common. Okay. So the solution, overtaking side distance, that is equal to VB into T plus B plus 2S plus V into T. So we have all the values. Your VB is always 0.278 into VB into T. Here 0.27 VB into T plus 2S. Here the 0.278 B into T. That's all. So S is equal to the formula for 0.2 VB plus 6. So VB we know for 6 is available. So we have to take it for 84. So S is equal to 22.8. If A is 9.81, okay, T is 4S divided by A. So 4S, 4 into S is 22.8 divided by A is 9.81. So that is 3.04 meter per second. T is time, that is for 13.11 meter per second. So overtaking side distance is, you have to apply for the T and S, okay, and resolving this one and get it for 177.66 meter. This is called as a overtaking side distance. Okay, this distance is enough for one vehicle. Okay, vehicle number A is transferred to the AB, okay, in transfer to the C point and transfer to the D point. That's all. This 177.8 meter, 6 meter, this is needed for overtaking. The next, if A is equal to 0.53, so overtaking side distance, that is equal to 763.26 meter. This is the answer. In case of A is 0.53 means. In case of A is 9.81 means 177 meter. That's all. Okay. So the definition, in overtaking side distance height, the obstruction is 1.2 meter. The obstruction is the vehicle. That's all. The next point, effect of gradient in overtaking side distance. What is the effect of a gradient? So vehicle sometimes fast moving, sometimes slow moving. That is neutrally we have to maintain it for A and B. Okay, positive means upgraded, downward means slow graded. That's all. So OSD, overtaking side distance, that is equal to D1 plus D2. So we know the formula for D1 and D2 formula. So vehicle distance is for this formula, VB into T plus VB into T plus 2S. So is generally for the both upgraded. Okay, so the overtaking speed, it should be always be considering for upgraded only. And also the downgraded means the vehicle compared to the plain area. Okay, so but the design point of view adopt overtaking side distance of the plain area, that is for overtaking zone. So it should be as compulsory. We have to provide for stopping side distance at all the instance. Okay, for that reason we have to maintaining for overtaking side distance is always higher than with compared to the stopping side distance. That's all. But OSD cannot be provided all the instance. It is provided at some interval. Okay, நம்ம வந்து இதுக்கு we not provided for this overtaking side distance for considering. Okay, this is for normal area, this is for normal area. Okay, one of a toll plaza, okay, one of maximum bus parking, area parking, that is for overtaking area. The vehicle is goes to the of this utilizing this extension spaces. Okay, the normal vehicles as goes to the normal speed. That's all. So SP1, SP2, SP2, SP1. Okay, so here SP1, SP2. The vehicle is in the point 1 and point 2. Vehicle is a point 1 and point 2. That's all. Okay, the total L it should be calculated. So SP1 means signpost 1. Okay, SP2 means signpost 2. SP1 signpost signpost. Okay, so starting of overtaking zone here SP1. So we needed to starting the time for overtaking. SP2 ending the time we are in the overtaking. Okay, that's all. So the length of the overtaking zone. So we needed to find for the length L, that is equal to minimum length 3 into OSD. Okay, this is for minimum length. Okay, for a question point of view, what is the minimum length for overtaking? Means 3 into OSD. This is the minimum length. So desirable length means 5 into OSD. Okay, question is, you go to find for a minimum length, we go to find for a desirable length. What is the value for 3 into OSD, 5 into OSD? That's all. The next. Intermediate side distance. Okay, this is for our area. That's all. So here we needed to find for minimum, and here we needed to find for desirable for normal values. But the signpost, this projection is not suitable for our national highways. Okay, so this projection it should be for bus parking. Okay, and for posting areas. Okay, crossing areas. That means we needed to provide for this kind of works. But other normal works it should be done for intermediate site distances. Okay, that's all. So so we need to provide for intermediate site distance. Okay, so the vehicles are normal areas to the left to right, right to the left only for a site post 1 and site post 2. So we needed to neglect this point. Okay, so this is called as the intermediate site distance. That's all. So as per Indian Road Congress, intermediate site distance, that is equal to 2 into SSD. 2 into SSD means stopping side distance into 2. The multiplication of the 2 times of a stopping side distance is called as an intermediate side distance. What is the reason? So this vehicle, okay, this was a 1 lane, this is the 2 lane. So we know for a stopping side distance, we need to provide for a stopping side some distance. It should be 2 lane, okay, lane 1, lane 2. For that reason, we multiply by 2. Okay, this is for intermediate. The total vehicle movement is stopping distance, safe stopping side distance into be of a same lane, that is called as a intermediate side distance 2 into SSD. That's all. So the headlight of a site distance. Next question, next topic. The headlight, the vehicle headlights are in the of a side distance means HLSD. So the one of MCQ questions available for abbreviate for HLSD. So headlight sight distance, HLSD, headlight sight distance. That's all. So here the vehicle is available. Okay. So here the obstructions is available. So this you can consider for this a single lane as a 3.5 meter of a width. So in the day and night, what the facings we have to following. So here the friction is 0.36. Okay, the vehicle is goes to the normal of a speed 60 kilometer per hour. The friction is reflecting for the vehicle speed. Okay, V is a 80 kilometer per hour. Okay, V is the speed. If 2.5, T time is a 2.5 normally as from the Indian Road Congress. The time taken it should be as 2.5 seconds. That's all. So the stopping side distance is equal to HSLD. Okay, we needed to stop this vehicle near the obstruction. Okay, so that is equal to HLSD. Okay, the sight light distance is covered to the fully length of SSD. Okay, stopping sight distance. Okay, so you can visible to the subsection clearly within the limitation of SSD. Okay, stopping sight distance. Okay, for that reason we equate the two components of SSD, that is equal to headlight sight distance. Okay, and SSD distance. That's all. So the height of the driver's eye level above the road surface is 1.2 meter. Okay, we needed to height is depends upon the capacity of the vehicle, car and buses, trucks. It should be have a different height, but we needed to provide for the eye level in the 1.2 meter height. Okay, so the 1.2 meter is onwards from our vehicle to visible all the obstruction, visible all the curb and all the barriers, all the medians, etc. The height of the vehicles in height light above the road surface is 0.75 meter, 75 centimeter. That's all. So the next for horizontal alignment. Okay, so we need to change the horizontal alignment to change the direction on the road alignment. That's all. So this is for the horizontal alignment. Okay, so our vehicle is in the RP is alpha. So vehicle is here. So here on the vehicle is here. This is the side distance point. We need to see the vehicle inner side of the left portion to see the obstruction means O. Okay, this is called as a horizontal alignment. To change the direction, vehicle, we need to change the direction of the vehicle means this one. That's all. So you can see curve of the varying. Okay, this is for the point. So the 600 meter. This is the radius r. There's a translational curve. This curve is called as a translational curve. The O obstruction point. So we need to r, that is the radius is equal to alpha. Okay, A point, C and B and C. Okay, vehicle is goes to the curve. Okay, within the alpha range. That's all. So definition for R into alpha means at starting of a translation curve. So we are in the starting point. Okay, we needed to definitely see opposite vehicle during the turning means that is called as a starting point. We need to see the vehicle. Okay, what is the vehicle capacity of the vehicle? What's the speed? Any obstructions? Okay, you needed to see an A point. So it is definitely to avoid the accidents. Okay, or the radius of the simple at ending of a transition curve. So R, this is we needed to provide for this R. Okay, an obstruction R. So this is our symbol radius. Okay, at ending of the transition curve. Okay, we needed to provide for one of arc from this point to here. So this 2 point coincide means this intermediate projections we needed to cut to visible all the vehicles. Circular curve. That's all. So is side distance. So when the length of the vehicle, the transition curve increases, the radius it should be decreases. Okay, what is mean by? So here the example at A, that is equal to R is equal to alpha. The vehicle of the R is 600 meter. The radius we need to find 600 meter. Okay, so where the increasing curving length. That's all. So for designing the transitional curve, length should be more. The vehicle length it should be definitely more for that reasons. The next, for a centrifugal force for P, that is equal to WV squared divided by G into R. This is called as centrifugal force of the vehicle in the curving of the area, transitional curve. So W, it is for the weight of the vehicle. V is for the speed of the vehicle. R, it is for the radius of the horizontal surface factor. So P by W, that is equal to V squared by G into R. So the Newtons per meter square by second into meter square by second. So no units occurred in the centrifugal ratio of the vehicles. That's all. So effect. Next topic for effect of a centrifugal force. What are all the effects are available? First one, tendency to overturn of the vehicle onwards about the outer wheel. Okay, this is one of the main reason for centrifugal force. Overturn. Okay, the tendency is main problem. The tendency is to be skid of the vehicle. Okay, laterally. Okay, of the outwards. This is the centrifugal force. The next, overturning effect. So these are the overturning effect. These overturning effects are inner side of the curve, that is in the P into H. We need to apply for A object, B to the direction of the vehicle. This view is available here. Okay, inner side and outer side. The vehicle is moving and curve, and it is go for translation. It is here. So the radius it should be maintained. Okay, this is outer side. This is inner side. So the notification W is for the weight of the vehicle, B is for the width of the wheelbase, H is for the height of the center gradient, external moment due to the centrifugal force P into H. Okay, so the restoring of the internal moment W into B by 2 due to the weight of the vehicle. Okay, weight of the vehicle is mainly component to avoiding the this type of collision effects. Okay. So the equilibrium equation summation of MB is equal to 0, P into H into W into B by 2. Okay, so this is for P by W into B by 2H. So we know the continuity formula, same procedure, V squared by G into R is equal to P by W is equal to B by 2H. Okay, this formula is important for overturning will not occur. Okay, we're finding this one. Okay. Mm, so just move to a recall. In the previous of this topic, okay, the expert examination point of view, the competitive examination point of view. So this is common for gate examination, TRB, AE, okay, IES, SSC. So 9 questions are expected from all the examinations. Okay, as per our civil engineering syllabuses. Okay, so you needed to find for this all the topics, the traffic engineering and highway. Okay, so traffic and highway transportation. Okay, this is mainly participations. Transportation, land, airway, waterway. So we needed to only focusing for land. Okay, airway, that is called as a railway and airport. Waterway, this is for a shipyard. These three important topics for our transportation highway engineering. Okay, transportation, roadway and highway, railway. Okay, this we needed to find. So most flexible of the vehicle, high plus way. Okay, that is called as a highway. Okay, higher speed, and for a clear way, that is called as a highway. Okay, so these are the formulas. Geometrical designs. What is for a geometrical? In the first author of the Indian Road Congress in 1934, this is the year for first code book we have to establish for Indian code for a construction of a road pavement. Okay, what is the construction? Length, it should be distance of the two district, any of the area, but width, it's so very important for clear pausing, side distance, stopping side distance, lighting distance, etc. So the width of the pavement also called as a carriageway. Okay, this is called as a carriageway. Vehicle lane 1, vehicle lane 2, this is called as the center line. Okay, so as per the Indian Road Congress, we have to design for this 2 lane and two-way traffic lane. That's all. So the maximum of vehicle dimension is 2.4. We needed to round up this value for at least 2.5 meter. For a single lane means we give the obstruction for 0.625 meter. For 0.625 meter, it should be clear. Okay, in case of single lane, for a clear way, 0.62, 3.75 meter we needed to provide. In case of village road, 3 plus 0.25. In case of a single lane, 3.5 meter, that is multi-road. Okay, and a 2 lane with a raised curbs, 7.5 meter. So curb, it should be for a drainage. Curb, it should be for a people walking way. For the reason we considering for a curb concrete element, it be 0.25 meter, 250 mm of a concrete curb. Okay, that's all. So the 2 lane of a without riser is 7 meter. Without rising, we considering for highways for 7 meter. So 2.5, 2.5, 1 meter is for center median, and 0.5, 0.5 meter for shoulder. Okay, totally it will take for a 7 meter. That's all. Okay. Okay. So today's class is okay. This video is uploaded in our HICET Prerana Gate Classes coaching. So you refer this videos in YouTube channel also. Okay, thank you all.
Thank you, sir.
ஓகேம்மா, தேங்க்யூ. நீங்களா வந்து கவனிச்சிங்களே. இது வந்து எல்லா வீடியோவுமே ரெக்கார்ட் ஆயிடுச்சுங்கம்மா. எல்லா சப்ஜெக்ட்டுக்குமே வந்துட்டு ஷேர் பண்ணிடுவோம். நீங்கள் எக்ஸாமினேஷனுக்கு உங்களுக்கு இது கண்டிப்பாக ஹெல்ப்ஃபுல்லாக இருக்கும். ஓகேங்களா? அதனால தான் ஸ்டூடெண்ட்ஸ் இல்லாமலும் ரெக்கார்ட் பண்ண சொல்லியிருக்காங்க. ஓகேங்களா? அதனால நீங்கள் கிளாஸில் வந்தீங்கன்னா கொஞ்சம் லைவாக தெரிஞ்சுக்கலாம்.
ஓகே சார்.
ஓகேம்மா, தேங்க்யூ.